Hi, it's great to be here. So my name is Mark Cheshire, and what I'd like to do is to take some time to look back to where things have come from. And I often find when you sit back and look up the stars, it gets you in a bit of a reminiscence mood to really do that, think about the origins of things. And I remember the days, it was back in 2008, that I joined this very small company in Barcelona called 3Scale. And at the time, there was one other company, Mashery, and these two companies were the beginning of this whole movement around APIs. I also remember at that time having a conversation with Mehdi. I can't remember, Arno, is he here at this event? So Mehdi's around. I haven't bumped into him yet, but I remember having a conversation with Mehdi, and he had this crazy idea. Let's have a conference, a meeting where we can get all these API practitioners together, and that was the beginnings of API Days, and that's 10 years have passed since. It's just amazing how time flies. It's also, when I look at the way that this community has evolved, it's tremendous seeing how things have grown and how much richness there is availability. You're at a great time. The amount of capabilities and tools that you have at your hands as API developers is a great time to be an API developer. So one thing that you may be thinking about when you look at this title is, okay, this is an API conference, but where are APIs in the title? I didn't see APIs. So don't worry, we'll get to that. And what this talk is about is really about a big change that's happening in the world of APIs. I believe strongly that we're coming upon a new era, and it's an area where we're going beyond REST APIs. You see a lot of seeds of this at this event. So you see topics on event-driven, you see topics on green IT, you see topics on identity management. These are not strictly REST API concerns, which is what the foundations of API Days was. And it means that there's a recognition that things are moving on, and this community has to embrace more than APIs. But at the same time, the thing that's missing is this holistic overview of what ties all these threads together that we're talking about. So that's what I hope to share with you here, a little bit of somewhat of a framework or a model to thinking about application connectivity in a broader sense rather than just purely about APIs. As I do that, I'm from Red Hat, and Red Hat is a 100% open source company. Everything we do in the community. Everything that the thousands of Red Hat engineers create, every line of code they create goes back into the community. And we believe firmly in the power of this innovation cycle, working with the community and sharing back everything. Nothing we do is kept proprietary to the company. And this model, surprisingly, is very similar to the model that Douglas Adams talked about in Hitchhiker's Guide to the Galaxy, that the Hitchhiker's Guide to the Galaxy, the true power of it is that anybody who's traveling through the many galaxies could all make contributions to that Guide to the Galaxy. And that's very much, it was probably one of the first comedic examples of open source development. First of all, I'd like to share what's the drivers around thinking about this model on application connectivity. So there's 4 key drivers. The first one is that businesses get value out of applications when those applications are connected. When you have applications working in silos, it's counterproductive to the values that the business gets out of the environment and the applications. So the more you can connect applications, the more value you can provide to business. We're in a world today where applications have to be portable. It could be for reasons of resilience, that you want to be able to provide failover. It could be that your you're moving workloads from on-premises into the cloud or from one cloud to another cloud. And so you need to be able to have that flexibility to move applications to where you need, whether it's moving it closer to data or some of the other reasons I mentioned. Third is that when you look at application connectivity requirements, it's really important to think about it from different levels of concerns. There are network concerns, which are, of course, critical, and there's also all the application level concerns. And you can't just take one view and look at those in isolation. It's really important. You often see different organizations and teams responsible for these different concerns, and it's important that these teams communicate and collaborate when looking at application connectivity solutions. And then the last one is that REST APIs, as I mentioned at the beginning, they're going further, and you see more and more things that are being connected together which are not REST protocols. You see an explosion around async APIs, event-driven. These are all important things that we need to embrace as part of application connectivity. So, as we're making this change towards this new future, a world of application connectivity, you need to start thinking about change around the organizational elements. That's the first important thing whenever you do any kind of change. And I take inspiration here from one of the greatest teams that ever existed, and that's the team of the Heart of Gold, the starship in HitchHackers Guide to the Galaxy. And you had the three great team crew, Zaphod Beeblebrox, Trillian, his second in command, Marvin, who can forget Marvin, the depressed robot, absolute classic. So this crew was so effective because each one of the crew had very different roles and responsibilities. And the same is true when you look at the different concerns around application connectivity. So you have the network layer, you've got the application layer, and then you have the business layer. And each of these layers of concern have different stakeholders who care most strongly about these. The network or DevOps team, the developer, and then the product owner. And the first important thing is to make sure, as I said earlier, that these teams are collaborating and working together. That do not let any one of these groups go off and come up with their own solution, take a siloed view to how they solve application connectivity needs. In order to be able to help this collaboration communication, I've got a model here to share, and this is at the beginning of a model to take and start to extend. So the first part of the model is to look at criteria by which you can evaluate what is the right connectivity solution that meets the requirements you have. There are 4 key requirements. One is around accessibility, second around security, then we have discoverability, and fourth, governability. I'll skim through these very, very quickly here. So, around accessibility, it's first of all thinking, what type of communication do you need between your applications? Is it your applications are being exposed beyond the enterprise? You're trying to build up an ecosystem, so that would be a typical north-south communication. Or is it within your enterprise that you're communicating applications, they're all collaborating together as part of a microservice architecture and more east-west type traffic? And then what's the nature of the communication? Does it need to be, is it good enough to have request-response synchronous requests? Or do you really need to have more of an event-driven approach? And what is the right model for what you're trying to achieve? And then looking at all the performance and resilience requirements. On security, I can't stress enough how important it is to get security baked in right from the beginning. I have seen too many examples of companies who've started and thought, we can make shortcuts when it comes to security in the beginning, and we'll harden it up as we have more serious use cases. And it's very difficult to add in good security later. So do focus at building in the right level of security for the data that you're protecting right from the beginning. Around discoverability, one of the great things about this community around APIs is how much work has been done to make it very easy for developers to discover APIs. The concept of developer portals and then open API specification to have a standardized way to document APIs. It's been one of the fuels to grow this community so strongly. So it's really important to think about those aspects of discoverability, regardless if it's REST APIs or async APIs or gRPC endpoints. All of these things, they all need to be discoverable. And the same whether it's for human developers or whether it's machine-based discovery for automatically connecting in a service network. And around governability, when you're doing a simple Hello World application, it may not be so critical to think about governance, but most of you in the situations that you're working with, I'm sure it's not as trivial as Hello World. So you do need to think about how to manage the full life cycle for the applications and the connectivity requirements you have, and how think about managing those in production, the availability and performance requirements. So those are the 4 key areas of criteria. And now I'll move on to solutions. Let me take a quick drink. When it comes to solutions, going back to Hitchhiker's Guide to the Galaxy, if you're looking for the solution on absolutely the best cocktail in the world, it's obvious, it's the Pangalactic Gargle Blaster. No one can make a better cocktail than that. But when it comes to application connectivity, it's not so easy. There are a lot of different options, and it's a bit more blurred which the right solution is. So next I'll take us through a quick whirlwind on the types of options you have, starting with the network layer, and then I'll move up through the application layer. So first of all, at the network layer, beginning with very simple and moving on to more complex scenarios. So very simply, at the beginning, you've got an application running in a cluster, and you need to allow requests to hit that application. And so the requirement is simply to stand up an ingress router to be able to expose that service to the external world. And then you also need the reverse. If that application is going to connect to something else outside the cluster, it needs to go through an egress router. So 2 fundamental requirements. Then it gets a bit more complicated, because let's say you want to build in some resilience, high availability, then you'll probably want to replicate that application in 2 different clusters. And in this case, you'll want a load balancer between those clusters and before it gets into the ingress. And then taking things even a step further forward, something that Red Hat's very much a strong believer in, open hybrid cloud, that you don't want to put all your eggs into one basket, into any one cloud provider. If you really want to make sure you can deliver 5 nines, it's better to make sure you're running on multiple clouds, or clouds and on-prem. And in that case, you have an external load balancer which routes first of all to the specific platform, and then you go through the load balancer between different clusters. So that's around just getting the basic traffic going. But then within the cluster, how does that look for service-to-service communication? So the first thing is things are made really easily in container platforms with Kubernetes. You don't have to worry anymore when you're trying to communicate between one service and another. You don't have to worry about IP addresses, host names, all that stuff. You just give it a service name, and the Kubernetes router takes care of... wrong door. Can we close this door? Welcome. We have started already. Please take a seat. So Kubernetes makes it really easy. All you have to do is provide a service name, and the router takes care of deciphering that and connecting you to the right IP address, the right service, and you may have multiple services running. Then, let's say we want to communicate to a service running in another cluster. Then you're actually going to have to expose that service to the public internet, going through the egress, and then another service will also have an endpoint available and may accept that request. So that would be a typical example of a REST API being exposed externally. But let's say you may not want to expose this. You may consider it opens up a vulnerability or a potential opportunity for hackers to break into your network and access your data. So there may be scenarios where you want to keep all of your service-to-service communication within a private network. You still want to have the scale of running in different clusters. In that case, one approach is to tunnel across clusters. And so with tunneling across clusters, you can build up a bridge between any two clusters. And it may be, though, that you don't want to create a flat network across these two clusters. And in that case, what you can do is, oh, I skipped one. That was the connecting across the clusters. And you can also have the option to connect directly any service with another service, so a service-to-service communication. This is a new community project called Scupper that allows you to do this, and you don't have to worry about VPNs or anything. Just build in a bridge between any two service points, and you've got secure traffic connecting those services. From one service, it looks like the remote service is actually a local service. So that's a quick whirlwind tour through the network layer. Then if I go into the application layer, the first thing around the application layer is to think, do you need request response type communication or an event-driven approach? And let me say, it's clear request response and REST APIs are ubiquitous, and the reason they're ubiquitous is there's such a great fit for so many use cases. But what I see amongst Red Hat customers is that the real growth is around event-driven. And the reason is it's a much better fit for most of the typical problems you have in businesses where you need to respond to events that are happening in real time around you. It connects the business better to the real world. And these things are not mutually exclusive, so you can use them in combination, but once you have connectivity in place, you want to have some additional boosters to help you with that connectivity. It may be, what are the patterns to be able to connect things together and to deploy reusable patterns? It may be out-of-the-box connectors, to, say, for example, to make it easy to connect to a SaaS service like Salesforce CRM. Or it may be that the service you're communicating with expects data in a completely different format. And so in that case, you want to build in a layer to convert the data before it reaches its destination. Another element of application connectivity is API gateway. I don't need to explain that here because this is an API event, so a standard API gateway to protect APIs. But then what is taking up and becoming a lot more popular is service mesh. So for east-west communication within a microservice architecture, to take a service mesh model. And here, the de facto is to have a sidecar approach where you've got essentially a mini gateway co-located in the same pod together with every service. And that's basically the model that's adopted by Istio and by Red Hat in its service mesh offering. As you go forward, though, what you start to see is that you're adding more and more gateways and proxy layers, and this doesn't make a lot of sense. And Red Hat is working together with partners in the community to be able to collapse some of this overlap and provide a more generic multi-purpose gateway that can solve these different use cases. One thing that I should stress is when it comes to service mesh and API management is not to think of them as two separate things. In a larger organization, you've got multiple different business groups, and typically when those business groups share services, they should treat the communication to different business groups as north-south communication, just like you do when you expose an API externally to the business. And so you really want to think about using service mesh together with API management. So we've gone through a quick survey of all the different options that are available. So now you're probably asking, what is the answer to the ultimate question of life, the universe, and everything? And the answer is the application community. Okay, cheating. So it's the application connectivity matrix. I'm not going to give you all of the details, but I'll give you a path to set you on. So this is the matrix, and it's basically a process. So the first step is to define the criteria, going back to those 4 criteria I mentioned. Define what's important for your application connectivity needs. Then to explore through things like this conference, what are the different connectivity options you have that would be a potential fit, and then to evaluate them based on the best fit to the criteria you have. So a very standard process to go. And you already told me that the answer is 42, but there is a catch that I haven't actually given you all of the answers here. So where we go to from here is to take this as a starting point and to explore, build out this, and think more holistically about application connectivity rather than purely REST. And with that, I'm going to skip the next slide. Just thank you so much for coming. So long. Thanks for all the fish, and looking forward to this next chapter together with your help. I've got time for a quick question.
Thank you, Mark. Are there questions in the audience for Mark? If not, I will ask questions.
One plug for my colleague, Ugo, who's over there. He'll be talking and exploring some more of these topics tomorrow morning at 11:05 a.m. So hopefully you can join us there or come over to the Red Hat booth and learn more about this. Thank you. Bye-bye.
Yeah, just have a question for you regarding the connectivity matrix. So there are many different tools, many different technology that people can use to connect APIs. Is there an API that will tell me which tool I have to use?
That's a great one to work on. Thank you.
Thank you.